our quadratics, we talked about that we have an x squared in our problem. Okay, we have that variable to the second power. We talked about how our graphs of quadratics, we have either U-shaped, if it is and you want to add this in, if it is a positive quadratic equation, meaning that a value, the value that's out front here, this value here, if that is positive, you're looking at it opening up. Your negative quadratic equation is going to open down, be in-shaped. Okay, you're kind of like a hill. We also talked about how the ones we had seen so far, we had a lot of them that we only saw about half of the equation. For instance, when we were doing the guy that was diving into the shallow pool from 35 foot up. And he dived in and came down. Okay. So the other things we talked about with quadratics, the last thing we left on was that our graph, it is always going to curve back on itself. In other words, it's going to turn around. Okay, and what we mean by that is that, for instance, this graph here, if we're looking from left to right, starts going to go down. It comes to a point or vertex here, and it's going to turn right back up the way it came from. Okay. Same way with any of these. Starts out low, it's going to go high, and then turn back the way it came from. Even this one here, we started out at 35, it went up just a little bit, and then came back down. Okay. So when we're looking at our quadratics, that's going to be our big tell for our graphs. Okay. So the last thing we have to look at is our exponential functions. Now, with our exponential functions, exponential functions come in the form y equals a to the x power. Okay? And what that means is if we see like an actual exponential equation, for instance, y equals 2 to the x power, which is the one that we used when our bacteria was dividing in that example. The key here is that there is a variable as an exponent. We have a variable as an exponent. Okay. Now, we have two different types of exponential functions that we want to identify. Okay. Hey, Chase, this is just in your notes. A separate sheet. No, I mean, we just have a separate sheet. Just have a piece of paper to be writing this down. Okay. So there's two types. The first one we'll look at is called exponential growth. Okay. Essentially what that means is that we are going to start out real slow, and it's going to work its way up real high. Okay? That's what an exponential growth equation looks like. Okay. And we get this anytime our A value is greater than 1. Okay, so even at just 1.1, anytime our a value, that value in front of our x as the exponent, is greater than 1, that's going to be exponential growth. Our other form of equation that we're going to see is exponential decay. What do you think that's going to look like? Very good. It's going to start at the top. It's going to start coming down real fast and just level off. Okay. This is anytime your a value is between 0 and 1. Okay. So exponential growth, exponential decay. So the big thing that we can look at graph-wise, our key things that we're looking for in the graph then are what? What do you notice about these graphs? First off, they do what? What's the easiest thing to see? They do what? Are they straight? No, what do they do? Okay, so the graph is going to curve. Okay. Now, does this one curve back on itself all the way? No. It's going to continue in the direction it's going, but by either a much smaller amount. So for instance, in our exponential decay, as we get down here, it's going to keep going down. It's just going to keep getting closer and closer to what we call our asymptote, and we'll talk a little bit more about that later. But it's going to keep getting closer and closer and never actually like fully cross there. Okay. With our exponential growth, we're starting out slow and then get it going up real quick. We're never going to get straight up and down. We're still always going to be moving a little bit, but it's going to look almost eventually way up here if you get to be almost straight up and down. Okay? So the graph curves. And it continues in the direction it started. Okay, so exponential growth is always going up through that whole process. Exponential decay is always going down through that process. Any questions so far? Okay, so just kind of a quick review. If we are looking at the equations and we're trying to decipher which type the equation is, the things we look for is first we look for if there's any exponents. If there's no exponents, we know it's linear, because all quadratic and exponential both have exponents. Okay. If there's a variable to the second power, that is our quadratics. Finally, if there is a variable as an exponent, those are our exponentials. So that's if we're looking at the equations. If we're looking at the graphs, those should be a little bit easier to see. Obviously, a straight line is going to be linear. If it starts curving back on itself, whether that be a full nice U or an N, or if it just barely comes out and comes down, that's going to be quadratic. If it's continuing the same direction the entire time, same way here, okay, and it's going to get closer and closer to a line that never touch, our asymptote, then that is our exponential. You will have to identify between exponential growth and exponential decay based on the direction it's going. If it's going down, it's decaying. We're losing things. If it's going up, it's growing. Pretty simple.